Hello everyone, my name is He Rui from the Hong Kong Polytechnic University, the School of Design, and it's my great pleasure to introduce you with our recent work, an interactive system for supporting creative exploration of cinematic composition designs. So now we shift our story time to 3D space. Excuse me? Well, cinematic composition design is a creativity-intensive task during the storyboarding stage of traditional filmmaking. Well, at this stage, the filmmakers would ideate on animation content in addition to its cinematic composition, which defines from what camera perspective should the story content be characterized for expressing intended emotions. In contrast, 3D filmmaking platform like Unreal, Autodesk 3ds Mask, Unity Unreal provides a real-time virtual environment where the filmmakers can explore, evaluate, and visualize numerous design options of cinematic compositions within such a real-time scene. Well, given this strength, we have witnessed many traditional filmmaking practitioners that borrow strengths to prototype and pre-visualize potential design options before formally committing to storyboarding. However, this creative process remains challenging, as the filmmaker still needs to meticulously manipulate the virtual camera and navigate through the ample design space within the real-time scene before they identifies the best design option. Well, to address this challenge, we design and develop a creativity support tool which we call Cinema Assist to facilitate this creative process. So at the core of our system is a degenerative model that can suggest distinct cinematic composition design options to fit the animation content and the according semantic context. So we adopted a human-centered design approach, inviting professional 3D filmmakers to recall their conventional design workflow in addition to reporting any difficulties they had encountered in this workflow. So all these three filmmakers have experiences using such platforms for formal 3D filmmaking in scenarios like digital game casting production or the pre-production stage of traditional filmmaking when they use such platform to ideate or pre-visualize potential design options before going to formal storyboarding. The user interface of our system comprises three components: a control panel for setting up the semantic context, a design panel for explore and record the design options at keyframe level, and another storyboard panel that explore design options at scene level. So these three panels can be integrated into any 3D filmmaking platforms, which has a scene view, where the filmmakers can manipulate the virtual objects within it and conduct the design, and a cinema view that visualize a camera's perspective to see through a specified camera perspective how the scene can be depicted, and its actual look can be seen from the cinema view. And another timeline window where the filmmakers can control the progression of the animation. Well, next, let me briefly showcase how we produce a camera work using this system for a given animation. So initially, the user can review the animation by dragging the progress bar on the timeline. Then, the user moves to the semantic panel to setting up the semantic context for the following design. Specifically, the user has to specify a default control camera for menu design and two targets of interest. In addition, user needs to specify a genre type and an intended emotion type for the following design. All right. Then the user formally embarks on the following design process. Particularly, the user can pause the progress bar on the animation timeline at a critical point, which is a keyframe. By clicking the plus frame button, the user can add a keyframe item on the design panel. Like what they did in their conventional workflow, they can control the default control camera to find a desirable camera pose and record its according cinematic composition to the keyframe item. Alternatively, when the user moves on to the next keyframe, rather than manual design, the user can also refer to the camera poses suggested by our system, visualized as inspirational light bombs in the scene view. Well, whenever such a light bomb is clicked, its corresponding 2D composition, the actual cinematic look, can be visualized in the cinema view in real time. The user can choose to accept this suggestion or further tweak it, adjust it to reach the most desirable outcome. Or the user can instantly click the review button to instantly evaluate the cinematic looks of all the suggested camera poses. So as long as the user clicks such a look, the system instantly map it back to its corresponding inspirational light bulb camera pose for the user's further tweaking. In addition, our system also predicts whether the suggested camera pose start a new shot. Our user can choose to decline the prediction or accept this. So in our case, we remove the tick in the new shot box. That is to say, the current keyframe item will follow the previous one. So when the user rehearses the animation by dragging the progress bar there, you will see camera motion rather than a cut. As well, the user can also explore design options told at scene level to see how the story can be told in various ways at scene level. To do so, the user clicks the two-story board button that move the confirmed keyframe items from the design panel to the storyboard panel. So these sequence will be regarded as a precondition for our system to give the following suggestions at scene level. So the user should now specify a time range and a time interval for sampling purpose. And then after clicking the recommend button, our system will go through the animation within the specified range with the sampling interval. Shortly, our system will suggest numerous various sequences that complete the remaining story that follow the previous sequence. So the user can quickly evaluate these design options. So whenever the user finds a satisfying one, by clicking the Adopt button, these sequences will move back to the design panel for the user's further adjustment. The user can update it or remove it whenever needed. According to the context of the current keyframe, the user can re-specify the animation cinematic context. For instance, here, the user re-specify. All right. Let's wait for a second. All right. The user can re-specify the genre type and intended motion type, and shift the targets from the male and female in this case to the male and the zombie. And accordingly, our system will give suggestions around the interaction between the male and the zombie. That's it. Anytime needed, the user can render the sequence on the design panel to see its actual look, to see the rendered footage in the cinema view in real time. All of these is conducted in real time. All right, next let me briefly introduce how we implement this system. At the core of our system is a deep generative model that aims to generate a sequence of camera poses whose 2D compositions will portray the keyframes within the animation, besides expressing intended motion types. Well, to represent the information in a keyframe, we predict the character's 3D poses. To represent the camera pose and its according 2D composition, we adopted the character's screen position in addition to 2 orientation angles. Our deep generative model consists of 2 modules: a keyframe feature extractor that can extract a keyframe, a feature vector from a keyframe. This vector will consist the context information around that keyframe. When taken as input, these feature vectors, the second module, the camera pose generator, will, in addition to inputting some semantics, this module can generate a sequence of camera poses. So here we see the camera poses as a language, film language. So we adopted autoregressive transformer decoder at the core of this module. To train such a model, we curated a dataset from 18 movies belonging to 3 distinct film genres: romance, thriller, and action. For each movie, we split it into scenes, and for each scene, we partition it into shot sequences. For each keyframe within a sequence, we predicted the full body poses of characters within this keyframe, and from which we calculated the camera pose information, in addition to the 2D composition. Well, to evaluate the usefulness of this system, we conduct a user study with 18 participants. All of them have experiences using 3D filmmaking platform for different purposes. But as we assume that different expertise of filmmaking could influence the level of usefulness of our system to their creative process, as such, we divide these 18 participants into 2 groups: animation background group and a non-animation background one. Well, during the task session, we require each participant to conduct 2 design tasks. The first one, to create a sequence of camera cinematic composition for a given animation without the support of our system. And the second design task, to create a sequence of camera cinematic composition for the same animation while our system is supported. So after these 2 tasks, we follow another semi-struck interview, inviting the participants to recall their creative process, as well as reporting their self-confidence towards the design outcomes of the 2 design tasks. We also invite them to give their satisfactory score to the usability of our system. It turned out that most of them feel more confident towards their design outcome after using our system, and most of them feel satisfied to the usability of our system. To validate these subjective feedback, we conducted another expert reading study. In this study, we invited 2 filmmaking experts to evaluate on the design outcomes of our participants. Particularly, for each participant, the 2 experts should rank their 2 design outcomes in addition to 1 automatic result generated by our system with random target selection. So in this case, the two experts give the first place to the one created with the support of our system, denoted as human plus Cinema Assist, while the second place to the one without such support, denoted as human. And the AI-generated one fell at last due to wrong target selection. So it turned out that the evaluation results differ a lot between the two groups. So the animation background group reached significant improvement within their design outcomes in terms of three evaluation criteria: continuity, novelty, and overall quality. However, for those in the second group, the non-animation background group, they seem to not have reached such improvement. So our experts commented that these people seem to have used wrong shot types that influenced the overall consistency of the generated sequence. So we perceive this phenomenon as a lack of film editing knowledge. So as the users could prefer more to use the keyframe level suggestion. When stitching these options together, they fail to maintaining the consistency of the whole sequence. So by the end of my presentation, I invite you to do a guessing game. So here are three footage rendered from the design outcomes of one participant in my study, in addition to one created by our system, Cinema Assist, namely the AI side. So could you guess which one of them is created by human, which one is by human plus Cinema Assist, human by AI, and which one is created purely by AI? Any guesses? Did you get it? All right, thank you for watching. My future work will extend the capability of this system to aid more storytelling scenarios, maybe in physical space, VR, AR space. I'd also like to develop a creativity support tool for facilitating animation content ideation on such 3D filmmaking platform, and I'm looking for a postdoctor's position to resume these research topics. Thank you very much.